Dear students, you are welcome to my Whiteboard program. Today we will take the class 10 Science, Chapter 4, third part, that is Carbon and Compounds. So last class we have done chapter part 2. Today we will discuss some major points like how to write the polymers of butane. Then we will come to the homologous series, its properties, then functional group, then nomenclature of hydrocarbons. So these are the main points today. Last class we have discussed what is polymerization and what is polymer. Today we will go some example of polymerization. So I have told you the polymerization starts at least the carbon atoms should be 4 in number. Then polymerization will start. So let us see the first polymerization, that is in butane. Butane formula is C4H10. That is butane alkane group C4H10. So let us see. Butane is C4H10. So its molecular formula is C4H10, but its structure can be made different way. So now we will come to, there is N-butane. One polymer of the butane is known as the N-butane. That is called the chain butane. Here we have to how to make the structure. How many carbon atoms are there? 4. Let us go for 4 carbon atoms. 4 carbon atoms. They are bound with the single bond, covalent bond. Now you see here the carbon has 4 electrons. One electron is making bond with this carbon. One electron is already engaged. So next 3 electron will be there. Then 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So the carbon will make 4 bond individually. Then we will put the hydrogen because it is carbohydrate. Hydrocarbon. So now we will put everywhere H, and H. If we will see, then the formula will be 1, 2, 3, 4, C4, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10, this is called the N-butane because it is straightway chain like. Then we will come to the isobutane. Isobutane also formula C4H10 because it is a butane. Let us see how we have to make the isobutane. So in isobutane, first N-butane we are taking 4 carbon in the straight chain line. But here we will take 1, 2, suppose 3. Then one carbon we have to make anywhere branch, suppose here. Then we will fill up 1, 2, 3, then 1, 2, 3, then 4, then 1, 2, 3, 4, then 1, 2, 3, 4. So now you put the hydrogen everywhere. Now you will get, this is H. Then you count how many carbon are there. 1, 2, 3, 4. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C4H10 is coming molecular formula, but the structure is different. That's why it is called isobutane, means branching butane. Branch is coming, carbon is making branch. Then we will come to the neobutane. Formula is same, that is called C4H10. So let us see how to make the neobutane. So 1, 2, then we will make 1 C here and 1 C here, suppose. This is the branch. Now 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Everywhere you put the hydrogen. Everywhere hydrogen you put. Then you count 1, 2, 3, 4. 1, 2, 3, 4 carbon are there. C4, H, 1 here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C4H10, but the different structure. So butane, which is C4H10, that can be written in different structure. So Isomerism means what? The compound having similar molecular formula but different structure. So this is similar molecular formula C4H10, 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 but different structures are there. So they are called the polymer. So the polymer of butane are N-butane, which is straight chain line, isobutane, which is just branch line, and neobutane, which is double branch line. So these are the isomers of butane. Similarly, you can go for the pentane also. That is N-pentane, isopentane, then neopentane. Similarly, you can do. So this is going to your what is called isomerism, polymerization, and of the butane. Then we will come to the homologous series. What is called homologous series? A series of hydrocarbon having similar chemical properties and each adjacent members differ from each other by CH2 unit is said to be homologous series. Homologous series means what? It is the set of hydrocarbon. That is it is a series of hydrocarbon. Now suppose CH, 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 CH. This is the set of hydrocarbon. Now it will be called homologous series if the each adjacent members will be differ with C1 and H2. 3 minus 2 is equal to C1 and 6 minus 4 is equal to H2. So their difference will be C1 H2. Again you see C4 minus C3 is equal to C1 and 8 minus 6 is equal to 2. So C1 H2. Again you see 5 minus 4 is equal to 1 and 10 minus 8 is equal to 2. C1 H2. Everywhere the difference is C1 H2. And they are all the hydrocarbon. So this is called the homologous series. In homologous series, what are the properties? Properties will be there. I have given you point 1, 2, 3 property I have given here. The first property is each adjacent member are differ with CH2 unit. That is I have shown you. Then second is that all the members have same chemical properties and are prepared with common process. Suppose this is called ethane, this is called ethane, propane, butane, pentane. These are the so this is the homologous series member, and all the members are prepared in the same method of preparation, and they are same chemical properties. Then number 3, that is they have same same general formula and their physical properties show gradation. That means what? That is called they have same general formula, because you see this is C2H4. That means this H4 is coming 2N formula, HCnH2n. This is C3H6, CnH2n, C4H6, CnH2n, C5H10, CnH2n. Same general formula they are prepared, and their physical properties are gradation. Their physical properties under the gradation means from here to here they will be gas, from here to here they will be liquid, from here to here it will be solid. So this is called the homologous series and their properties. Next we will come to the functional group. What is functional group? The functional group are defined as specific atoms or group of atoms or ions which are part of a larger hydrocarbon chain impart characteristic properties to the compound. So this is called the functional group. Functional group means what? Simply you see functional group. Here I have written OH. Here I have written COOH. Here CHO. So these groups, these are the number of atoms, group of atoms or group of ions. When they will be attached with the parent hydrocarbon, give the characteristic properties of this parent hydrocarbon. This is hydrocarbon, this is hydrocarbon, this is hydrocarbon. When this is attached to here, its property is known to us. When this will be attached to here, then its property we can understand. When it will be attached to us, its property will be different. So from here we can understand what type of hydrocarbon is it. For example, when C2H5 coming CnH2n plus 1, that is alcohol. family. So here OH is used. OH is here called functional group. So when with this compound OH is there, then this compound we can say alcohol. But you see exactly same number is there, but COOH is used. Then this compound will say that is called the ethanoic acid. It is called ethanol, that is called the alcohol. It is called ethanoic acid, that is called the carboxylic acid. Then same compound combined with the CHO, it is called the ethanol, that is formaldehyde. So because of these groups of atom, we can see the difference of the characteristic of this compound, this compound, this compound. So this group which gives the characteristic of this compound are called as the functional group. For example, very simple example I will say, if there are one boy and one girl are seated on a bench, and from a little distance you will be asked to know who is girl and who is boy from the back side. How can you understand who is girl and boy? By looking the hair, long hair. So long hair makes you that this one is girl, and short hair makes you that this one is boy. So long hair is known as the functional group of the girl, because from the long hair you can say that one is girl only. So here long hair is known as the functional group of the girl. Similarly, from here OH, from here COOH, from here CHO, so we can understand it is alcohol, it is carboxylic acid, it is aldehyde. So they are known as the functional group. I think clear? Now we'll come some example of the functional group. So this is OH is a functional group for alcohol. So it is written like that, ROH. This is the hydrocarbon group, and OH is written. Then that name will be at the last will be OL. If methane plus OH, then methanol. If ethane plus OH, then ethanol. If propane plus OH, then propanol. So alcohol group is ended with the OL word. Then aldehyde. Aldehyde is functional group is CHO. We can write CHO in this structure also. CHO. So if it is aldehyde and CHO group is used there, from methane it is called methanol. From methane it is called ethanol. From propane it is called propanol. AL will be added for the this group CHO functional group. Then ketone, CO. So it can be written in this formula. So this is ONE. Suppose methane, methanol, ethane, ethanol, propane, propanol, like that. Then carboxylic acid. So its functional group is COOH. If COOH is attached, then we can say that compound is carboxylic acid. Then it is written as like COOH. So it will be ended with OIC acid. OIC. Suppose methane plus COOH, we will call methanoic acid. If ethane plus COOH, ethanoic acid. Propane plus COOH, propanoic acid. So it will be ended with the OIC acid. Then ester, this is the functional group of ester, and it will be ended with the OID. So these are the last means suffix of the name. These suffixes are used after the word of the. So these are the known as the various functional group: alcohol, aldehyde, ketone, carboxylic acid, ester. Alcohol OH, aldehyde CHO, ketone CO, carboxylic acid COOH, and ester is COO. So these are known as the functional group. Now we will come to the nomenclature. So nomenclature means what? Hydrocarbon nomenclature. That means how the name is given to the hydrocarbon compounds. When you are taking birth, your name is given. Suppose your name is Sai Lipsita Rai. So your Sai Lipsita is coming from your either Panditji is saying, yeah, your parents are saying it will be started with S. Then Rai is from your title. So similarly, hydrocarbon also written in same way, that is two names are there. First name depends upon the carbon atom, second part depends upon the hydrogen atom. How many carbon atoms there? According to that first name is started, and how many hydrogen atoms are there? According to that last ending is given. For example, when C, you have to memorize this one. C1 means we will start meth, C2 means eth, C3 prop, C4 bute, C5 pen, C6 hex, C7 op. C8 oct, C9 non, C10 gen or deca. So if any compound, suppose it is given here 2, then C2 means what is there? Eth. We will start from here eth, that is called eth. Then we will see how many hydrogen are there. So there are 3 conditions are there. If hydrogen follows 2n plus 2, suppose 1 is there, then hydrogen will be in this formula how many? Now 4. 2n means 2 into 1 plus 2 means 4. If hydrogen will be 4, then this following this formula, that is called the ANE, alkane group. Then we will call meth, ANE, methane. If there are only hydrogen will be 2, that means it is 2n formula, that is ENE, ethene. So meth, ENE, methane. If there will be no hydrogen, then it is nothing. So there is no member. Similarly, when C is 2, we called eth. And if hydrogen is 6, that means 2n plus 2, then ANE will be written. So eth plus ANE, ethane. Then if it is coming double, that is 4, that is 2n formula taking. So it will be ended with ENE. Then eth plus ENE, ethene. So if it is 2 is coming, that means 2n minus 2 formula coming, then it will be YNE, eth plus YNE, ethyne. So according to hydrogen, ANE or ENE or YNE will be ended. One more example I am giving, C3. C3 means prop. We will start prop. Then we will see how many hydrogen. If it is 8 hydrogen, that means it is coming in 2n plus 2 formula. So we will put last ANE, prop, ANE, propane we will call. But if hydrogen is 6, that means it's double, 2n formula. Then it will be written as ENE, prop, ENE, propene. If it is 4, that means double minus 2, that is 2n minus 2 formula. Then we will end with YNE, prop, YNE, propyne. So in this way, we can name the different hydrocarbon compound. That is called the nomenclature. So in this way, we can say, suppose for example, I am showing here, if I say C6H14, what will be the name of this C6H14? Let us see. C6 means, you see, C6 means hex. I will write here hex. Then H14. H14, how it is coming? Now 6 double is 12 plus 2. So 2n plus 2 formula it is coming. 14 is coming. 2n plus 2 formula means ANE we have to end. So ANE. So hexane. But if it will be 12, suppose 12, then what will be? Now this is the double, means 2n formula. 2n. 12 means ENE. That will be ENE, hexene. But if it is 10, suppose C6 2n minus 2 formula, that means 6 double is 12, 12 minus 2 is equal to 10, then it will be YNE, hexane. So you see C6H14, hexane, C6H12, hexene, C6H10, hexine. In this way it is. So first name is from carbon, second name is from hydrogen. Are you clear, I think? So this is called the nomenclature. So now today up to this we have to go. Now I remind you, if you want to learn non-stop and without coming to school now, as it is not regularly open, so you should subscribe this My Whiteboard PK in YouTube. Then you will get continuous classes. So now chapter 4 is going on, so I am going very small way and you can understand it part wise. So if you will subscribe, then notification will be there. Then you have to like and share for the more and more benefit of your friends also. It is totally free channel. No need to pay anything. It is only dedicated for the students. I think clear? So this is today's matter. So it will be this chapter will be continued further. So wait for that class. Till that, goodbye.